Okay, thanks everyone. I think I have the immense luck to have co-authored this paper with the chairman of this session, so be lenient with me. Right, so this paper was co-authored with Theo, along with Algan Tezel from the University of Nottingham and SK Moon from Ajou University in Korea. And yeah, it's about tokens, right? And how can blockchain tokens be used in the AEC industry? The thing is that sometimes we have the tools, we know what we want to solve, but we don't have the problem formulated well enough, or maybe the actual question. And one of the questions we would like to explore in this positional paper is exactly if we believe there is some kind of using tokens, if there's some kind of value of using tokens in our industry, right? So just some really, simple and plain fundamentals here. The process of tokenization is the conversion of data into a random string of characters, okay? This string is called a token. And we do this to protect the sensitive data by substituting it with non-sensitive data. And when it comes to blockchain tokens, these are digitized, tangible, and intangible assets in smart contracts that represent a certain share of asset ownership, right? So it's a more specific thing of a token when we're talking about blockchain tokens. And the thing is that tokens in blockchain applications and things like peer-to-peer economies and decentralized applications actually hold value because they represent tangible and intangible assets which after being tokenized can be exchanged. And we have seen that tokens in blockchain infrastructures can be used in supply chain management, investment financing, property management, and stuff like that. However, they are not used as much in AEC. I mean, blockchain implementation in our industry is nascent as it is, and some deeper consideration in tokens is even more nascent. So regarding tokenizing in a blockchain ecosystem within construction, if we flip what a token is, we are talking about converting digital or physical built environment assets into tokens to encapsulate their value. And as I said before, we haven't really considered what is the actual value of doing this. Yeah, we can, probably, but why do that? And when it comes to the process of converting and creating tokens, which is token engineering, how can this be contextualized in our industry and research field, right? So we did a literature review, and we kind of found two groups of publications on tokens. Some that we named very aptly more conjectural studies, hypothesizing on tokenization for our industry, and some more elaborative studies that have actually conceptualized or even developed tokens or have studied the development of tokens for construction, right? So indicatively, we had some insights from conjectural studies, for example, that asset tokenization in crowd sale smart contracts can initiate decentralized fundraising events, that tokens can enhance the integration between the monetary and material flows in construction supply chains, that they can improve infrastructure asset liquidity and transaction efficiency exactly through the process of tokenizing actual assets, and many more insights like that. And some indicative insights from the more elaborative studies that actually studied and even developed tokens is that we can have, for example, there was a study talking about a project bank account blockchain model which provided liquidity in the case of non-payment by the client, right? Through a blockchain-based tokenized security service provider by financial institutions. So we had a third party there, which is kind of counter to what blockchain is, but this was embedded in a tokenization structure, right? And for example, we have other things like in architectural design, we have topological graphs that organize non-fungible tokens corresponding to building components and work with that. So there are interesting things we can do with tokens, but is there a value in actually doing these things? So we tried to have an epistemological discussion in this paper. Maybe epistemological is too heavy of a word. I would say a conceptual discussion about what is the concept of the value and the underlying principles for tokens within construction. And we came up with this simple model that tokens have a duality in their quality for our construction industry. They can function both in technical terms as for the thing they are, this random stream of characters, but also they hold some kind of economic value, especially if we tokenize assets that can be exchanged, like for example in real estate. And this is connected with how well token can be embedded in a construction ecosystem. And this is some kind of, here we're talking about a kind of contextual understanding of whether we can use a token or not. And these two concepts and underlying principles kind of feed into the method with which the token holds value, which can be direct, utilitarian, security, or pegged, like for example stable coins, and also a kind of a contextual awareness of the sociotechnical parameters of the specific construction application we're talking about. And these factors in our conceptual model actually create what is the value of the token for our industry, right? And when it comes then to the second question, which is about token engineering, we conceptualize three main phases with which token engineering can be contextualized in construction. The discovery phase, where we define the system goals, identify potential stakeholders, and map the token ecosystem. This was the discovery phase. The design phase, where we determine the actual functions of the system that describe the system state as captured in the discovery phase before. And the deployment phase, the final one, where we have the technical implementation and we have considerations on utility and governance. And of course, there also we do some kind of play testing here. So we believe that tokens can hold value for construction, and token engineering can be contextualized in construction. But then there is another question that came up in our conceptualization. What is the difference of cryptoeconomics and token engineering, especially when contextualized in our industry, right? Right, thank you. So token models in cryptoeconomics are developed to optimize an automated market towards stability, right? And in this conceptualization, decentralization is understood as a computing property for censorship resistance, right? So tokens are used as economic incentives introduced in blockchains to make centralized business models based on surveillance and control unfeasible. So they are not feasible if we're going to use tokens, and we use tokens in order to not make them feasible, right? And this kind of fits into the structure of what cryptoeconomics is. However, decentralization in the architecture, engineering, construction industry is something different because it has a physical and geographical dimension as well. So the autonomy of local economies as a planning instrument and the political stance of somehow geographically distributed power and resources are considered in a different way, for example, in urban planning. So this kind of political economy is not based on neoliberalism, but rather on mutualism and ideas of the commons, right? And that way, tokens and token engineering in construction is distinct, or can be distinct from cryptoeconomics, because on the protocol level, tokens can be rewards for maintaining the blockchain's common infrastructure. And on the industrial levels, they can encapsulate incentives to create and maintain a common infrastructure. So it's the ideas of the commons that might make token engineering and tokens valuable for construction itself, and not necessarily surveillance and censorship. So to finish off, tokens can hold value potentially for our industry, either direct value via payments, utilitarian value, for example, in governance, security-related value in object representation, and, as I said, pegged value, for example, in terms of stable coins. This value can be reflected in the infrastructure of the blockchain, but also in structuring incentives in economic terms. It could be realized through systematic embedding in the relevant AEC application or ecosystem. And we should take into account sociotechnical parameters when we are implementing token engineering. And to conclude, this is, with this conceptualization, what we want to spearhead, so to speak, is the consideration of a new political economy. That was our whole initial goal with this paper, or at least we cannot do it with this paper, but we want to initiate the discussion doing that. However, of course, we have limitations. There is an absence of an empirical analysis challenging this postulation. It's just a conceptual paper. And there are a lot of nascent questions that have come out after we did this job, this work. Is this health value significant enough to attract the interest of AEC stakeholders? Are changes in established work practices worth the investments that justify the investments that would be required for implementing token engineering in our industry? How many and what types of tokens are needed in any case? There might be more than one. And how can collaborative value be maximized amongst AEC stakeholders and interested parties, despite the fact that we are in a competitive industry, right? So as future work and taking off from this positional paper, we would like to classify, or others, to classify tokenization opportunities by thematic area, for example, circularity or sustainable development, and classify associated benefits, challenges, issues, and opportunities of token engineering and token usage within AEC. And from all the handsome gentlemen that wrote this paper, thank you very much for your attention.